Amortization is a process of paying off a loan that includes all accrued interest by making a series of regular and equal payments. This is a formula we will use to calculate monthly payments on a loan. Keep in mind that we know all the variables in this formula. It's a new formula, but we know all of the variables from earlier work. So for instance, little t is the time in years. We call that the term. Little r is the annual interest rate as usual. Little m is the number of compounding periods per year. Capital R is the periodic payment. And capital P is the present value of the annuity. And as usual, little I is the interest rate per period. It's the annual interest rate, little r, divided by little m, the number of compounding periods per year. And little n is m times t. All of this we know. And the best way is just to jump in with an example. So let's start one. Ms. Rigsby made a $40,000 down payment on a $165,000 house and took out a 20-year mortgage at 6% compounded monthly on the balance. How much will the monthly payments be? First of all, we write down our formula, and then we realize that even though it's a $165,000 house, Ms. Rigsby paid $40,000 down, so you have to take that away because she's not going to borrow $165,000. She paid $40,000 already, so she's only going to borrow the remainder, which is $125,000. So that becomes the present value, and we plug it into the formula. We also know that little r is 6%, so we can calculate little I by plugging in 0.6. We know that m is 12, their monthly payments, so we can also plug m in. And we know that t is a 20-year mortgage, so t is equal to 20. And now that we know those values, we can calculate little I and little n. So little I comes out to be 0.005 and n comes out to be 240. So we plug those numbers into the formula, and now it becomes basically a calculator problem. If we add 1 to 0.005, we get 1.005, and then we have to raise that to the 240th power using the power button, the X to the Y button on the calculator. If we do that, we find out that 1.005 to the 240th power is 3.310204.476. It has to be plugged in two places. We can do that. Now I'll tackle the fraction on the right. I want to do the calculation, subtract 1 from the number up top, divide it by 0.005, and that comes out to be $462 and 0.0408952. On the left, I need to multiply those two numbers, and I get 413,775.5595. And finally, divide both sides by 462.0408952, and we'll end up with $895.54. So if Ms. Rigsby takes out a $125,000 loan at 6% compounded monthly for 20 years, she will end up with monthly payments of $895.54. Let's follow that up with a couple of other questions. For instance, what if I want to know how much Ms. Rigsby will pay the mortgage company over 20 years in total? Think about it, that's pretty easy. What she's going to pay is $895.54, that's her monthly payment, 12 times a year for 20 years. So really you just want to multiply the monthly payment by 12. That tells you how much she pays for a year, and then multiply that by 20. That's how much she's paid over the course of 20 years. And you end up with a total payment of $214,929.60. So if Ms. Rigsby takes out that $125,000 loan at 6%, compounded monthly for 20 years, she will end up having paid the mortgage company almost $215,000 over the course of that 20-year period of time. One more question. How much interest will Ms. Rigsby pay the mortgage company? In other words, We know how much she's paid in total, but how much of that is interest? And that's also pretty easy. If you think about it, the total amount of interest Miss Rigsby has paid is just the difference between all the money she paid in minus what she borrowed. The difference is the interest. We know, we just calculated, that she paid $214,929.60. We also know how much she borrowed. She paid a $40,000 down payment on a $165,000 house, so she actually borrowed $125,000, so we plug that in. The difference is the total interest. So Ms. Rigsby paid the mortgage company over a course of 20 years almost $90,000, $89,929.60. So once you get in the hang of, in the flow of these, working them is fairly simple, and you can ask various questions based on the original set of circumstances. Let's look at another example. Bob can afford to spend $200 each month on car payments. If he can get a 4-year auto loan at an annual rate of 12%, what is the highest selling price that Bob can afford for a car? Keep in mind, the selling price is just the present value of an annuity. In other words, it's what it's worth now. The selling price is the car's value now. So we'll be using the same loan amortization formula. But this time we know capital R and are looking for capital P. Before, we were looking for a monthly payment. Now we know, using the same formula, that Bob is going to make a maximum of $200 a month car payment. And we want to figure out what the present value of that annuity is, which represents the selling price that Bob can afford to pay. So now it becomes, again, a matter of plugging into the formula correctly and being careful with your calculations. So we know capital R is 200, so let's go ahead and get that in there. We've got to calculate little I and little n, so that means we've got to figure out what R and M and T are. Well, it's a 12% annual rate of interest, so little r is 12%, which is 0.12. It's monthly, so M is 12, and it's a 4-year loan, so little t is 4. We plug 12% or 0.12 in for R, 12 in for M, and 4 in for T, we can calculate little I and little n. So little I is 0.01, and n is 48. Now plug those values into the formula and start the calculations. If we add 1 to 0.01, we get 1.01. Plug that in. Now we need to raise 1.01 to the 48th power, and that's going to show up in 2 places in your formula. So using the power button in your calculator, the X to Y button, you get 1.01 to the 48 is 1.1612226078. Plug that in. I'll move over to the right and start those calculations. So the highlighted value I want to subtract 1 from, and then divide it by 0.01. So if I subtract 1, I get 0.612226078, and then if I divide that by 0.01, I get 61.2226078. Don't round these intermediate values off. Plug that in. Now I want to multiply on the right by 200, and that gives me 12244.52156, and then divide both sides by 1.612226078, and I'll end up with a present value of $7,594.79. So if Bob can afford $200 monthly payments over a 4-year period, the most he can afford for the selling price of a car to be is $7,594.79.